let's go over to the EDS part now. And I mean, these particles, we want to analyze those elemental wise. So we can close all these things. Let's say we have, but the map we had perhaps is not so bad actually. Perhaps it is smart to have the map. I mean, how many particles do we have here really? It's not so many particles, I think. I think there were more particles up in the corner here somewhere. So here there are more stuff, right? And also some big silver stuff. Yeah. So let's go here now, 700 again. All right. So we go up to the EDS part there, and we can go to description of specimen. There. And then we can choose new specimen there, like that. It's not coated either. We say mark the tick mark there and choose.
Okay.
Yeah. Then we can, you see we have the feature selected there now. That is for the particle analysis, so you keep it on feature.
Okay.
So then we go to detect feature. And here we want to make an initial scan and choose where the particles, which particles that we want to detect, so to say. So if we go around here, it can be nice to have a picture. I mean, here there is a few particles at least. So let's start from here and just click start to make a scan there.
Just start?
Yeah, start the scan. So there's two ways to approach this. One is to just take a basic image like this, preferably the backscatter if you have like salt particles like we have and so on. Or you can do a EDS map directly and work from that. But let's work from this backscattering thing. And now you see it has pre-selected, you see it says features here. And it says color by class. We can change that to just the color by threshold. So this means that it detects everything. It thinks everything that is red is a particle.
Okay.
But we see obviously there is edges of the flakes, and so then we can change that by changing that window. So that profile we see is the number of, what shall I say, detected particles versus the size of them. So since we see that big bump, that is of course just the noise zone.
Yeah.
So if we shrink that red window so it becomes on the higher range, from the left side. If you drag it upwards, then you see things goes away. So now you see it's just a few ones, right?
Yeah.
So then you can adjust that so you see that the ones that you're interested in is shown.
Okay.
Now we see it's about 9 particles there. So we can remove the smaller ones, so take it a little bit up. I just want to make it not take so long time. So try to move it upwards until you have like 5 particles left. Yeah, something like this is fine. 8 particles. So what we see in the right part here now is the size of them, right?
Yeah.
And there is no classifications or anything and so on. So the next thing we want to do is we want to analyze them by EDS. So if you click start, yes. Oh, okay. Oh yeah. We need to switch tab.
Okay.
But it just rescans the image here. So we will get the same thing back now. Okay. So we go to the next tab, Acquire Site, here, and then we click Acquire now. Then we see it starts to scan each one of these particles we have detected. So, and then you see it makes it like class 1, it says there.
What does it classify them by?
Yes, that we can set later. So the idea is that the classification is that we can program the machine to distinguish particles. And we can choose to distinguish them by size or by chemistry. So we can say that we want the class 1 particles to contain potassium and chloride and be of a certain size. Then we call that class 1. And if they contain silicon instead, then we categorize them as class 2 particles. And so we can tailor make that. I think all these particles is like some kind of potassium chloride or something like that. And it also has some kind of silicon stuff involved there also. So now when we have scanned, now we see that for each of our, if I click on 8 here, then you see it marks it out. That is the particle 8. One can sort them by size. So here you see the biggest one is that one. That's the top one. And then if I scroll here now, we can see here is the elemental composition now. Say sodium and so on. So if I click on single, then it takes a image of it and it do what shall I say, this EDS measurements on it for each particle. So I can click here. This is the other particle. I can click on this one. That's how this one looks like. You see this one contains silicon. Well, this one, what did it contain? One, mainly silicon, and so on. So here we can continue here and choose setup classification. So here it says class 1 now. So we can just remove everything here. You can take over the control here.
Okay.
So there's 2 ways of making classification. One is you can click on a particle. Then you mark it perhaps, and then you click new class. There you see. So then it adds, what shall I say, it looks on all the elements it has detected, and then it chooses some kind of range span on that.
Okay.
But when you do it like that, it can be, there's always variation between particles, so you need to go through that list. Here it really says it must, you see it's clicked, must be detected. Yeah. So it must contain all that within that weight percentage range.
I see.
So there can be very harsh constraints there. So this is one way of doing it. And then you can click on another typical particle you see and make that into another class and so on. But we can do a more simple way, and that if you delete this class, here's a trash can here, and then you click here, and then we can choose not morphology, but we can choose chemistry, and we choose silicon, and the total counts there. We choose silicon there, and then you click. Okay, you need to make new class first. And then you click add. And you can move that menu away. And then you use the trash can on everything except silicon here now. So we only want to mark them as class 1 if they contain silicon. So that's like the very simple one. So remove all silicon there. No, remove everything except silicon.
Okay.
So we don't need aspect ratio either. So you can choose to also sort them by size. And then we can choose the maximum, it can be 100% silicon, it doesn't matter. And then
save?
Yeah, save and apply, you can choose there. So now we have classified, you see they become red, all of them, so they all contain silicon.
Okay.
So that now we have made a class, our silicon particles, class 1. So then we can continue now. So now, obviously we have the case that we have a very small view field. and we have 6 particles, 7 particles. So if we want to have more statistics, then we need to do stitching. Right?
Yeah.
So that's the next tab there. So if you click on this run, and then you can click on automate, and then we can choose new area and choose rectangle as preferable. Click next. And then we can choose, then we show the same thing as the snapping tool that we need to do top left corner, bottom right corner of the stitching area. So then we can choose the first point to be where the stage is now. So if you click accept, it will put just those coordinates up there.
Okay.
And then we need to do the motion again, right? So let's move the stage 2 millimeters to right. That was minus, right? Minus 2.
Yes.
And then it was plus 2 millimeter, right? Like that. So now we have a new position. We can choose accept, import that. So now we have top left, bottom right, 2 by 2 millimeter. Click next. Then we can see here it will be 4 by 4 images, 16 images it will take to scan to cover the area of interest. And let's do that. So finish. And click run. So then you see there's this map. That striped green means that now it is acquiring EDS data in that image. And then it will categorize particles from the EDS data, and then it will go through all these ones. So we just wait for the whole picture here.
Is there some sort of estimate on how much time it takes?
Yeah, I mean, you remember when we scanned initially? And I mean, since it has such a high beam intensity, so it goes pretty fast. If you look, you will see it will soon be fully green. It depends on how many particles they contain also. I mean, it goes and scans each particle individually. You see?
Yeah.
So perhaps 10 minutes. So it's like if you want to scan large areas, I mean, you need to have optimized the system. I mean, you cannot scan for hours on each image.
No.
So you need to have something that goes pretty fast. But it's very nice to have these training sessions, I think, also to talk about these more special functions, because normally we don't have time to train people on these features. And especially this kind of particle statistics is like a very classic problem, research-wise. And to correlate elemental data versus morphology of the particle and where they are. That's like very powerful. When we talked about, I mentioned that this problematic when you have like small, large view field, low magnification. When you are in that scenario. There is something similar to that, and that is when you're talking about depth of field. If you have a sample that is very rough, and then on this machine there is a scan mode called the depth. If you choose the stat, then it optimizes so you get a little bit more depth of field. But if you are in a case where you have huge roughness, millimeters and things like that, and you want everything to be sharp, then you can improve the depth of focus, because that depth of field depends on the working distance. So when you are very close, then the beam needs to focus, a lot. The beam converges to the spot at very high space angle. But if you move the sample down and increase the working distance, then that angle of the beam becomes narrower and narrower. And then the depth of field is increasing. So if in those kind of scenarios, it can be nice to actually run at you run it at high voltages because you want to have a nice beam. And then you pull the stage all the way to the bottom of the chamber, 150 millimeter perhaps. Then you get a superior depth of field.
Yeah.
But because if your roughness is millimeters, then of course you don't have the need to have like high magnification because you want the overview and have everything in focus.
Yeah.
So then one can use excessively high working distances. Almost halfway now. All right, it is done. All things is green. You can click on the review part here. Next time there.
Okay.
So now we see the area. It's a much bigger area. You see the scale says millimeter here because we scanned, I think it was 2 by 2 millimeter. And now we have, is it 50 particles or something like that?
54.
That we have scanned.
60 particles, I guess.
Yeah, it has an ID number. You can, if you click on ID, you can sort. Yeah, it says 60 in the top. Yeah, yeah, that's correct. So it became 60 particles on that. So that's a very nice demonstration, I would say. So 60 is. We would like to have about 100, I guess, at least, to get some statistics. But it's a good start. And we can also see that it says class 1, then we have a big bunch that is no classification also. And we see they are green. So that means they are outside. They probably contains less than 3 of 8% silicon. So if you scroll over to the right, you can drag here, we can look how this non-classified, what kind of silicon do they have?
Bunch them by, yes.
Yeah. So
Okay.
if you look on the silicon there, you see they don't contain any silicon. So what do they contain?
Okay.
If you look over to the right there, I think they might be these potassium boys. You see there is potassium.
Yeah.
Yeah. So add a new class of potassium.
Okay. Chemistry.
Yeah, you need to choose potassium. Click no on the count, total count. Click there
Oh, yeah.
and
Right.
potassium.
Add.
Yeah, and then you choose the maximum 108% you can choose. And what did they have? They have a few percent. Let's say more than 2%, 1%.
Okay. What do I do?
Yeah, here you choose 1 and 100.
1. Yeah.
So everything that is more than that. Yeah, but the maximum must be 100.
I thought I did.
Oh yeah, you did that.
But they're still not classified. So what's the problem?
Yeah, that's what I'm wondering. Yeah, but okay, if we looked at apparent concentration, the real is 0.16.
Oh, okay.
Okay, so drop it then to 0.1.
Okay.
Right, 0.1.
All right.
Do we get some?
There's still some.
But we have some total counts there also. Can we remove that one? Yeah, no. Apply and stay. Now we have class 2 there. So,
There's still some.
yeah, but they don't fulfill the criteria. So they're,
I wonder what they contain. But there's no potassium there at all. We have calcium.
yeah, seems to be calcium in those. But they could be calcium in the other ones as well. Also. So, but I mean, it shows the ID at least, right?
Yeah.
So,
Okay.
So this is how you do this. Very nice tool.